Okay, we will begin in 1 minute, okay, because I think still some students have not joined. Okay, let's begin. So last time we talked about because the reason of lab 4, we talked about the VLAN, right, virtual LAN, and then previous class we talked about RIP and OSPF, right? So these are so-called intra-domain routing, okay, within an autonomous system, AS, okay. We actually started this slide where we were talking about interdomain routing, BGP protocol. Okay, so I will quickly go through what we left over last time, right? So RIP and OSPF, you should remember, right? So OSPF is called link state method, right? So Dijkstra algorithm. Okay, RIP is called the distance factor. Okay, BGP is called the path factor we'll see today. Okay, BGP is really the only protocol, okay, that is used for routing in the network layer, okay, between different AS, okay, among different AS. So we know that within an autonomous system, you also have routers. Those routers are called interior routers. But if you are on the border gateway, which means you have a link that goes outside your own autonomous system, right? This is called the BGP router, border gateway protocol router. It runs the BGP protocol. And the internal routers usually run the OSPF. Okay, and for each autonomous system, it has a unique number identified. We call it ASN, right? AS number. And for example, AT&T has a couple of, not just a couple, right? So quite a list of ASN allocated to this service provider, right? So and for different service providers, we will have different AS numbers. Okay, and for different institutions, we will also have AS numbers. Okay, and these are called inter-domain routing. Okay, and it's different from within a autonomous system, intra-domain routing, right? So we want a simple but uniform protocol, right? So everyone runs the BGP protocol if it's a border gateway routing. Okay, and this is quite similar to our distance vector protocol, right? Like the RIP protocol, but it's different. Okay, it's not just a distance; it has an entire path. If you remember our RIP protocol, it actually only records the distance to the destination, also with the next hop router. Okay, but this BGP protocol will remember the entire path. Okay, BGP protocol is pretty complicated, so we will really give you just a high level idea. We will not go too deep there. Okay, but even so, it's a concept that very important. Okay, BGP, right? So you need to get an idea what it is, right? But we will not have a lot of reasoning like the algorithm, this kind of thing, like when we talk about OSPF and RIP. So BGP protocol, the full name is called the Border Gateway Protocol. Okay, it's run by the BGP routers at the border gateway. Okay, and so it's a de facto interdomain protocol of the internet. Right, every AS communicating with others on the routing information, just based on the BGP protocol, no other protocol. Okay, and again, just like the distance vector protocol, BGP as a path vector protocol, it runs a Bellman-Ford algorithm. Okay, it's still the Bellman-Ford algorithm, not the Dijkstra. Okay, and additionally, it has some so-called policy. Right. So, for example, I don't want to route through certain AS. Okay, and so it's a very simple protocol because it should be simple, right? Just because it's run by every router. You cannot make it too complicated. A lot of configuration, right? It still can be a little bit complex. Okay, you need to manually configure some of the preference that you want, right? So for example, you don't want to route through that path, right? Because it's too expensive. It's competitors or AS that you are not peering with, for example. Okay, and once you send whatever intra domain, right? So it will not be seen by the world. Okay, but if you send anything that is through BGP outside your AS, okay, This is called an advertisement, which means everyone will see it. Okay. Oh, by the way, I see something in the chat. Oh, so Adil asked a question about what is policy-based routing protocol. This means BGP can specify a preference, right? So, for example, I don't want to route in ABC, right? I want to do ADC, for example, because maybe ABCB is my competitor, right? So AT&T and Verizon, for example. Anyway, so there's some policy you can specify. We'll see that later, okay, shortly. So these policies are actually driven by economics, okay? We'll see that shortly. But just to keep in mind, there's some policy that you can set in BGP. And importantly, whatever goes to BGP is called advertisement, right? Because, you know, everyone will see it. It advertises to the entire world, okay? And so errors, if you have an error, it can screw up the traffic globally, okay? So it will disrupt the internet connection, okay? Connectivity. And so the policies here are really not driven by whether it's efficient or not, right? It's really driven by economics, right? So economy, right? So how much would it cost to route, okay? Because when people providing service to you to route your packets from one location to another, right? They want to get something, right? It's a service provider. You need to pay them, okay? So actually, money matters more than just your quality, right? Your latency, throughput, etc. Okay. So not just by performance. I say if it's a shorter path, it's the lowest latency, but it's expensive, or it's my competitors' AS, right? I won't route it through it. Okay. So this actually economics is a dominating factor. Okay. So let's see an example to understand why this policy can happen. Okay. So firstly, you have a service provider, right? So like a Verizon, and you have customers, right? Connecting, right? Customer pay the provider for services, okay? And then they can go through this provider to the internet and to get service, okay? And you can have different service providers peering with each other, right? So because, for example, you know, these service providers, sometimes you need to send a message to peer one, right? Then you don't want to pay peer one, right? You are supposed to pay peer one. And but peer one may also need to route some traffic to peer two, right? And in order to route through peer two, you need to pay peer two, right? To serve their customers, okay, something like this. Okay? You can peer one need to send something to peer two, but peer two may also need to do something here, right? So that's why they have this link. This is called the peer link, okay? P-E-R-I-N-G, peering, okay? They are peers, but they kind of it's like now I serve you, you also serve me, right? So we cancel each other, right? We don't pay each other. Right? It's like we are paying each other, but we have a peering like agreement, right? So then we can route through each other, but we don't pay each other, okay? Because it's mutual, right? So okay, but you cannot do this because, for example, if you look at the peering links, it's just the 1 and 2 are peered, 2 and 3 are peered, right? If you wanna send a packet from peer 1 to peer 3, but 1 and 3 does not have direct peer link, okay? You cannot do that because if you ever want to do that through the peer 2's router, okay? Peer 2's autonomous system, right? So then peer 2 is like helping you with some communication workload, but you are not paying peer 2 for that because it's not directly serving peer 2's customer, right? So the reason the peer 1 and peer 2 are peering is because you are serving peer 2's customer, okay? If peer 2 receive your packet and say, hey, it's not to my customer, it's to peer 3, another service provider, it will not forward you, okay? It has no incentive to do that. But if you still wanna, like, even if you have no peering, right? So you still wanna route your customers packet to the other customer, then you probably have to do a upper level service provider, okay? Like so if we say that the customer tier 1, right? So the second level service provider usually tier 2, then this could be tier 3, okay? So this tier 3 router, right? So then you have to pay this upper level service provider to route to those other service providers' customers that you are not directly peering. Okay? So you can see clearly that there's a motivation, right? So that people will allow you to route. Okay, either when you are helping him, he is not helping you, right? So this is one example. Okay, another is, hey, you need to pay somebody, right? Then they will route this. Okay, otherwise there's no way you can route through to peer through. Okay. Any questions here? Again, it's possible that if you send directly this path, right, this is going to be faster, higher bandwidth, but unfortunately you have to go through the path on the top. Okay, from there. Okay, this is because of the economics incentive. So here, the tier 1 ISP peering is something like looking like this, right? So you can see pretty much it's a clique, right? So everyone's peering with everyone else. Okay, this is because everyone has some customers, and they may communicate with somebody else customers, right? So you want to peer with each other so that when you route through directly, you don't have to pay each other. Okay, it's like these two, if they are within this tier 1 service provider, maybe they are also peer. Okay, so that you don't have to go to a more expensive like a service provider to help you. Okay. So this is AS level topology, right? So basically, this diagram is like every point is a, this is I forgot what is the name of this diagram, but it's a in data visualization, which is a branch of data mining, right? So there's a different kind of diagrams, right? This is one particular diagram showing, for example, this is really for this kind of very dense graphs, right? So if you have each node is a maybe a service provider or AS, okay? How many are you peering with, right? So you will add link to here, and to here, right? So only plotting a circular shape, right? Circular graph, you can see clearly. Otherwise, it will be a mess, okay? And there's also maybe the weights, right? So how many customers you're serving, and it's closer, maybe the more customers you're serving, okay? So this helping you to be able to visualize how things are going. So this is a topology long time ago, right? So in 2003, okay, if you can see it. I think this may be blocking. 2003, right? So now it's more complicated for sure. And the peering actually is kind of like a war, right? So it's a in the commercial world. Right? So basically, the reason you want to peer, let's say we find these two are peer, right? So why they are peering? This is because once you peer, right? So you reduce the upstream cost, right? For example, now customer want to go to provider and go to this customer, right? Then you need to pay the provider. But this customer, this service provider, which is now a customer for the up level provider, right? Need to route through your customer, right? You need to pay that provider. So in that case, it's gonna be more expensive than, for example, you build a peering link. I think I should call. You build a peering link directly between yourself. Okay, don't go through another provider. And if you build that peering link, route directly, right, and it's going to be faster. Okay. Right. So that's one motivation. Okay. So you can reduce the upstream cost. You don't go to the upstream, right, to the upper level service provider. Okay. Another is improve end-to-end performance, because once you go to the top layer and they route, you use the control. Maybe they will route for maybe a latency of 100 milliseconds. But maybe if you directly add a link between yourself, right, these two service providers router, it's 10 milliseconds. Okay, so this will improve the end-to-end. Okay, and and oftentimes this may be the only way to connect to parts of the internet, right? So because maybe you so you how to say this, right? So maybe you are in a very small corner, right? So in the you're not at the very center of the internet, a very rural area or a tribal area, right? So then what you can do is you need to find a peering service provider, peer with that service provider, right? Then you can finally ultimately go to the internet. Okay. And so you want to access to part of the internet, right? Okay. And but there's also, because it's a war, right? So oftentimes there are also some reason you don't want to peer with another service provider, right? So if you are a service provider, okay? Because you would rather have customers, right? If you peer with the other people, then basically you are serving, yes, for example, this guy is serving this guy's customer, right? What you wanna is, hey, don't, like AT&T is helping Verizon, for example. hey, Verizon customers just go to AT&T, right? So then I don't help Verizon, okay? If you are confident enough, people will feel, hey, AT&T is more convenient, right? So they will switch, right? So you probably want to directly serve the customers instead of helping others, right? And another is, for example, yeah, this is the same reason, right? Because peers are often competitors themselves, right? If you can attract their customers to your own network, right? So why do you even help others, right? Okay, and so this is incentive. Okay, another thing is that you know the peering agreements has a date to expire. Then you need to renegotiate. Maybe next time, maybe your peer will say, "Hey, now I want you to pay me something because I'm helping you more than you're helping me." Right. So this is a kind of, if you don't want to pay, then you need to find a way. Right? So okay. So sometimes there's some reasons that you don't really want to pay. Okay. So peering struggles, struggles in the ISP world. Okay, with extreme contention. Okay. Basically, because they themselves are competitors, they're competing for the customer, right? And also, agreements are usually confidential. For example, if you look at here, right? So if you have these Verizon and AT&T, they are trying to sign a contract, whether they peer or not, right? CenturyLink will not see it, right? So it's confidential. Okay. If CenturyLink want to route through AT&T to some customer here, maybe this time they're not peering, right? So you never know whether the original path will still be valid. Okay. Okay. Next, let's look at. So there are two types of BGP neighbors. Right. So there's here you can see the protocol names. Okay. So IGP is called the interior gateway protocol. Okay. So what it means is it's again the gateway. Right. So you will send, but it's interior. It's different from your OSP. So this is all BGP kind of thing, right? So within here, you want to run a interior gateway, okay? But when you're on the border, right? So on the border, okay, you will run the BGP protocol, right? So instead of the IGP, the BGP protocol has two types, okay? Two types of BGP. The first is called eBGP. The second is called the IBGP. So what does this mean, right? So here, eBGP are those orange links we show here, right? So basically, the routers on the two sides are belong to different AS. Okay, they are not in the same AS. Okay, so this is a key difference. Another is what we call the IBGP. IBGP is called an internal border gateway protocol. Okay, right. You can see here these links are within the same AS. Okay, the important thing is that unlike your OSPF, etc., okay, right, the IGP protocol, your IBGP protocol is a BGP protocol, okay, but it's a within your AS, right? So you may feel confused why within AS I still need a BGP protocol, which is IBGP. We will show that in the next slide, okay? But just keep that in mind. If these are the border gateway routers, between these border gateway routers, you can't be running the IBGP. Okay? But interior router, you will not run that because it might not even know the protocol, how to run that. Okay. So this is, for example, a full so-called IBGP mesh, which means each of those routers are the border gateway routers. It has some link going on. Okay. Any router here will have some link go outside your link. Okay. These are the border gateway routers. And if, let's say, you have an eBGP message, right, come from outside another AS. Okay. What will happen is it will use the IBGP protocol to synchronize to the other routers. Okay. It will not run the internal. So the question is, why do we need IBGP? Right? Why don't we just use the OSPF? Right. The reason is because OSPF does not including the policy information at the BGP. So the IGP, the interior OSPF, is designed without considering the path, right, and the policy. Like you cannot route through the peer, etc. Okay? So these are not there, right? So that's why you need to have another upper level, like BGP protocol, right? So you can attach those additional fields. Okay, so this is one important reason. Another important reason is to prevent the routing loops within the AS. Okay, so because so this is directly, linked to the other border gateway router. Right? So otherwise, you will have those. If you remember, we have the RIP protocol that can have, message propagate very slow inside your AS, and it can loop forever. Okay. So IBGP updates, do not trigger the announcement. Okay. Announcement, advertisement, they are the same thing. Okay. Announcement, advertisement, they go to the global network. Everyone will see it. Okay. But if you send it within an AS, no matter whether it's OSPF or your IBGP, right? So you just update. It's like read only. You don't tell others. Right? So you just take the information and update. Okay. That's what we have here. All right. So is it clear so far? Any questions? Yeah, if you have, I see a question on the chat. Let me answer. Okay, so the feedback is none. So let's continue. All right, so remember for the RIP protocol, right? So it's a path vector protocol. Okay, it's not a path vector, right? It's the distance vector. Okay, BGP is similar, very similar. Okay, but it's called the path vector protocol. Okay, it's not just a distance vector. Distance vector, you have two columns. One column is the distance to every interior router and the border gateway router in your AS, right? But path vector is basically saying, hey, for every other AS, how do we route? Okay, and this path information also there in addition to the like distances. Okay, so this is called a path vector. But you are still running the Bellman-Ford algorithm, right? So because still, if there's no additional policy, the default one will be I want to route through less AS. We will see that shortly, right? So we have, the path is actually, we maintain here as a so-called AS path, right? A sequence of autonomous systems, right? Okay, so it's not a, internally there could be many routers, but again, I don't care about how many routers internally you go, let's say from AS to border gateway router on the left-hand side, right? From here to here. Maybe internally it goes to 3 interior router, but I don't care, okay? I just think, hey, you go through one AS and the cost is 1, okay? The reason also very reasonable, right? Because when you go through some AS, there's some delay and there's some unwillingness, right? Because maybe it's not your AS of the same company, okay? So that's, the cost is more on the economy rather than, the real latency, okay? So you want to just count the AS and one probably less AS is better. Okay. So the AS path is, has additional information. It's like distance vector, but it has additional, like the other AS around the route to the destination. Okay. Here, for example, right, so you will have, hey, I want to route to this destination, network, AS4, and the path should be 2, 3, 4. Right, so we'll go 1, 2, 3, 4, all the way to here. Okay. The second will be, hey, I want to go to 130 at this destination, which is AS3. Okay, it's 130 here. Then I will go to A2, A3. Okay. And then the last one is 110. Right, so this is here, and AS5, I will go this path. Okay, you can see the entire AS path. Okay, the path is only AS, not anything else. Okay? AS path is recorded as one additional information here. And this is also used for loop detection, right? So if you find a loop, you will be able to find it from the AS list, okay? And you can then, also you can apply policy. Let's say, hey, I don't want to route through, I don't want to route through certain AS, let's say AS3, okay, you can do. So if you don't have any policy there, then we use a default choice. The route with the fewest AS is chosen as a priority, okay? So here's a simplified view of the BGP operations, right? So you first establish a session using TCP, right, on a particular port. So, this is actually kind of like in the application level, right? So because this TCP connection is a reliable connection with IP address, and then port is, the port is delivered to the BGP, right? It's kind of running some applications. Okay, it's actually go to the transport layer to establish connection, because when the border gateway routers, they need to maintain certain connections, just like a handshake, and periodically check whether each other are alive or not. Okay, we'll see that later. So it's actually kind of more advanced. It's kind of in the transport layer. And then you will exchange active routes. So maybe here I have some routes that I know, you have some routes that you know. You exchange it, okay, using announcement. Okay. And finally, you may find, hey, some route is no longer viable, right? Maybe a router is down, or AS is down. Another possibility is maybe another path is going faster. Okay, then you need to update. It's an incremental update, right? You need to tell this router, this also need to tell you. Okay, so you can think of this is like whenever you have some update, you just exchange. This is quite similar to the distance vector protocol we see earlier. If you remember, right? Whenever you find that hey, probe adjacent distance is faster or longer, then you notify on it and trigger another round of convergence, propagation of convergence. Okay, so there are 4 types of BGP messages. Okay, the first is called open, which means you will establish a peering session. It's like TCP we will see later, right? So you have it's not connectionless, it's a connection state. It's not stateless, but you have a state maintained. Okay, you do establish a peering session there. Okay, and then you need to do handshake at regular intervals. Let's say every 30 seconds or 30 minutes, right? You do a handshake. So hey, you are still alive there, right? And then if you really want to close this peering, right, you need to shut down the peering session, right? The reason we need to do this kind of establishment and tear down is because after you are in this session, right, so then you can just route without handshake, negotiation, all those things, right? So you are safely routing through the peering AS, okay, right? You can just send it. This is much faster, right? Because each packet you need to choose this route, and then the router will have to follow. Okay, if you frequently do these operations, it will be very inefficient. So you do this upfront until the point you don't want to peer again. Okay, and there will be also update. Update will announce, right? So we call it announcement or advertisement, right? So we'll announce new routes, right? Or we can withdraw some previously announced routes. Maybe it's no longer there. For example, we can also withdraw, or it's unreachable. Some router is down. So what is announcement? Announcement is more like the IP prefix plus attribute values. Okay, so IP prefix is something like this, right? So this is 16-bit prefix. Okay, the first two segment of the IP address. And so this is basically announcement to which destination, right? And then you have attributes. One possible is a path, right? Okay, and there's some additional attributes that we will see in the next slide. Okay, so the BGP attributes basically you can have, for example, so-called a local preference. Okay, local pref. So this is like a local preference policy to choose most preferred route, right? So you can say, hey, if possible, try to take that route. Okay, even though that route has more AS, but I really trust those AS, right? So let's use these AS if possible. Okay, so this will override the default fewest AS behavior. Okay, because maybe some shorter path, some AS is really risky, right? It will steal your information, etc. Okay, you don't want to go through that, right? So this is called so local preference. Okay, this is to help you choose the best path, right? And so there's also a concept called a MAD. MAD is the full name is called a multi-access discriminator, right? So this specifies the path for exterior traffic destined for internal. Okay, so what it means is, for example, right? So let me see. So let's say this is your AS, okay, and you have multiple broad gateway router, right? And you are here, right? This host is. Right? So how should you route it? Right? So whether the traffic should enter from here, right? Maybe this will be a different path than if you enter from here, right? Okay. Then you need to specify, hey, this is a multi-axis, right? So whether I want to go through this guy or I want to go through this guy, this will lead to ultimately totally different, paths. Okay. And this basically also choose a peering point for your network, right? Because maybe here you have some peering relationships, here you don't have. Right? So you prefer to go get the traffic from this router. Okay. So there's also some import rules, and there's also some export with. Right? So like what route advertisement do you accept, which I should ignore. Okay, and there's also export. Right? So which route should I send to? Right? Maybe I should not send certain route information to my competitors. Okay, or maybe it's to some customers. They don't care about some upper level routes that the service providers send. So you may not forward these to the customer. Okay. So as a summary, so we have the route selection. Right? So the first is, local preference. Right? So we will first choose whether the local preference can be enforced. Okay, and then we will do the so-called traffic engineer. Right? We will see whether we can find the shortest AS path, which means the least number of AS on the path. Right? Or we can choose the so-called lowest multi-access. Right? So map. Okay, so discriminator. Right? So we have each one have a cost, and we want to choose the lowest cost to be coming in. Okay, and we can also choose the lowest IGP cost to BGP. So what it means is so here if you have AS, right, and you have two boundary routers, okay? And you are here, right? And if you have no preference to the destination, both paths is okay, right, to here. Then the next is you choose the lowest IGP cost, right? So because here it's shorter, here it's longer. Of course, I will go through this one. Okay? So these are the preference. Okay, this is the order of preference. First, you will try to meet your local preference, okay, the highest priority, and then you will enforce these. Okay, each one is more important than the one at the bottom. Right? So if you do have preference on this, then the interior path is secondary. Basically. Okay, you will first meet the. I see some question in the chat. Yeah, so I don't know how to answer this. So basically, we are talking about the concept of AS, right? So there's a student asking whether go to different LANs. So AS could have multiple LANs. Okay, so because if you look at LAN is whatever is connected. This is the LAN. Okay, this is the LAN. Okay, you connect by Ethernet switch, for example, right? And then you connect another interior router. Okay, so but the entire thing is an AS. Okay, right? So it will go through different LANs possibly, right? Depending on how the physical topology of the router is looking at. Maybe if you want to, your host is at this LAN, and your egress, BGP router is here, right? Of course, it should go through this LAN to here. It's possible, right? So, but typically, I think it will directly go through the routers. It will not go to other LANs, I believe. Okay, it's interior routers are connected. Okay, router to router. Okay, it will not, because the only reason you send the traffic to the LAN, this port to the LAN, is because the destination is here. I think it's interior router, but it will not go into a LAN. I hope this clarifies the question. Yeah, it seems that it should be. Right. It will travel through the interior routers to your final LAN, but it probably will not go to other LANs. Okay. So last is if all these are the same, right? So there's a tie basically, right? So you want to break the tie. So then remember each router we have an ID, right? So then we can choose the lowest router ID. Okay. So anyway, you need to choose one particular route, right? You cannot flip. It's a route. The preference of route is stable. If I send multiple packets, the first packet, the second packet, the third packet are passing through the same route. Okay, even though the two different routes are equally costly, right? So, but you don't want to, hey, this packet one goes through this route, packet two goes through that route. Okay, you want to stable. Another thing that we need to keep in mind is the concept of AS path. Right? So, AS path is not shortest path. Okay. AS path means the least number of AS you pass through. For example, from the source, you go through here, and here, and here, and here. So you see this pass through 4 other AS, right? So altogether 5 AS in the path, right? And on the other hand, if you pass through this AS and go to here, destination, you have only 3 AS on the path, okay? Right? So so this is 1, 2, 3, 4, 5 AS. This is 1 AS, 2 AS, 3 AS. So which one will be preferred? Of course, this one, right? This has the shortest AS path, only 3 rather than 5. But does that mean that the path is really shortest, the latency shortest? Sometimes it's not, okay? For example, you pass through here, then you go through some routers, right? So all the way to here, right? Because they are belonging to the same AS, but maybe, for example, this router is on, let's say this is UAB, right? It's like on this University Boulevard, so like the router deployed like this, okay? You cannot, because there's no physical link directly from this router to this router. You have to go all the way here. So actually there's some delay, for example, along the way, okay? Right, so maybe it's even longer than here, because maybe here you go to this border gateway router, immediately go to this border gateway router here and here, right? It could be a little bit faster than here, but again, our preference by default is choose the least number of AS on the path, not considering any interior elements. Okay. Let me see if there's a question. So Alex, can you clarify a question? I don't quite understand your question. Yeah, it's okay. So maybe we can discuss that after the class. Okay, then you can just let me know. Let's continue. Right. So here this is the animation showing. Hey, we have 4 hops, right? 4 hops through 4 additional routers, not incoming to solve. But here we have 9 hops. If you count, it will be 9. Okay, and we only have two additional routers inside this. Okay, so actually this one is preferred. So another very famous term that you probably heard of when we mentioned about BGP is called the hot potato routing. Okay, so what does hot potato routing mean? Okay, right. So here let's assume that we have a source and we want to send a packet out. Okay, right. So which path will we send? So one way is this, right? So basically we can send through this router and then it immediately go out all the way to the destination. In another case, it will go to this, but this again, it can not go out because it has no egress outlet. You have to go to here, so you have 2 hops internally. Then you go. Okay. It seems that this is better. It seems this is better because 3 hops. This is so many additional ES. So here we have 3 hops in total: 1 hop, 2 hops, 3 hops, and 3 hop paths. Okay, and here we have 5 hops: 1, 2, 3, 4, 5. 5 hops. Okay, so but the cost is actually considered lower because it's so if you think about the cost, this is called hot potato. It means whatever packet you get from from outside, right? So you want to route through outside. Okay, so you want to get it out of your AS as soon as possible, right? Because once it's out of your AS, it's other people's duty. You don't pay that. You are not serving that packet anymore. Okay, it will ultimately deliver to the destination, even take longer time. It's fine. Okay, because it's not using my resolve. Okay. Well, here, if you are doing this, so you will need to go to this router need to do additional results. You go to this router. Okay? So if you think about it, it's like a hot potato, right? So these are different people. If you take a hot potato, immediately throw it out to another person, right? You don't want to hold it for a long time because then you will be burned. Okay. So ridiculously, it will take this path. Okay, not this path, unfortunately. So it will take the longer path, right? Because it's a hot potato. You throw it out immediately to this guy, right? If you hold it, even if basically you will find the closest egress, right? If otherwise, you hold it for long and you have 2 links, bandwidth occupied, and the router do the forwarding operation. So this is so-called hot potato routing, hot potato principle. Okay. Any question here? Right, I think let's first take attendance. Okay, it's a good time to take attendance. And to save time, I will, again, last time I think we take 334 a lot of times. Let's just sample quickly of 333 and sample more denser, okay, in 532, okay. Quinton, are you here? Quinton Coley? I will call 3 times, okay. Let me see, there's a chat. Okay, I see you in the chat. Karin, I hear.
I'm here.
Karin Maha.
I'm here.
Okay. Alan Landers, I hear.
Here.
Okay. Andrew McCormick, are you here? Andrew? Okay, let's call the last person. Okay. Actually, Jack is not last. Jack Sanchez, are you here?
I'm right here.
Okay. So now we will take another list, which will be more intense, extensive. Let's call every 5 people, 1 in every 5. Adil, I see you are here. 1, 2, 3, 4. Okay. Hamasi, are you here?
Oh, yes, sir, I'm here.
Okay. 1, 2, 3. Okay. Chancey, are you here?
I'm
Chancey
here.
Davis?
I'm here.
Okay. 1, 2, 3. Okay. Sai Garnett?
Yes, I'm here.
Okay.
Yeah, I'm here.
Got it. Okay. So Trey Nelson? Trey Nelson?
Here.
Sorry,
I'm here.
Not here, right? Okay. 1, 2, 3. Okay. Clark Run?
I'm here.
Okay. 1, 2, 3. Joshua Taylor?
I'm here.
Joshua Taylor?
I'm here.
Okay. All right. So that's attendance for today, and yeah, let's continue. Okay. Import routes. Okay, so these are the import rules. Remember, we have the import and export rules, right? Okay, so for example, let's think about this is for example ISP route. Okay, and here you have some, this is a service provider AS. Okay, and here you have some customers. Right? We are using this heart-shaped, orange, dark orange shape, shape to mean these are the customers' routes. Okay, that they sent. Okay, and from the peers, they also have some routes that you want to import, right? Share with you. Okay, the upper level service provider also have something. Okay, these are the oh, these are the grids. So use a square. Okay, and these smiling face is what you already know. Okay, and you are exchanging those announcements with others. Okay, so you see all those things, for example, because they are sending this stuff to you, right? Now you can have some certain import routes, right? So which routes you should import, which you should not. Okay, you can decide that. Right? And export routes are similar. Right? So now that you have so many newly known routes, who you want to send, right? Usually for the customer, you need to send customer get all routes. Right? They know how to route it. Okay, their routers knows how to route it. Okay, and then if you go to your peers, right? So the peers you want to also share with them, the customers, right? Because the reason you are peering because you want to serve each other's customers. Okay? You also want to share with them what you know, right? We probably don't want to share with them other peers' information, right? Because if, for example, if this peer is paired with you, it's just a kind of contract with you. They are not directly peering, so you should not share those information like I don't know which, maybe this color. Okay, means the information from this guy. You should not share to this guy. Okay, and similarly, you should not share those things from the provider. It's providing servicing you. That's your secret, right? You don't share with others. Okay. So these are the export rules. You export certain stuff, right? So you don't export, for the customer you export everything. Others you don't export everything. So and this this route is a money generating route, right? So keep in mind, if you are peering with each other, you are not generating income. You are just exchanging the service, right? Because you serve me, I serve you, for example, right? Only when you have to rely on some upper level service providers, right, to route to another place. Okay, then you are paying somebody. Right? So this is the money generating. This is not peering is not generating. Okay, but similarly, if you have this route, it's money generating. The customer has to pay you so that you route for it. Okay, so vertical is money generating, and horizontal is just peering. Okay, it's not generating money. Okay. All right, so what problem is BGP solving? Right, so because for example we have the interior protocols RIP, OSPF, and ISIs. Right, so so these are basically the problem shortest path. Okay, for BGP, is this short path or shortest AS path? The answer is actually we've already told you. We have a lot of additional BGP policies, right? And we are not just looking at the short path, right? But we need to know what are here, okay? Because knowing these things can help us analyze the BGP policy, whether it's reasonable or not, right? And then we can design BGP extensions, right? So, and some unreadable ones we can change, right? Okay? And you can also explaining if some routing is not functioning normally, right? So you can explain what's happening there, right? Because you know the incentive of the route, okay? Right. Otherwise, you see, hey, there's a route there. Why it's not passing through? Okay, right. So you know this underlying problem that it's addressing, then you will be able to understand the anomaly. Okay, and it also gives us a deeper understanding of the problem. Okay, so the problem that we're actually addressing is called the stable path problem, right? So we want to convert the shorter path, but we maybe a rhythm path, but we don't want this flip, right? So maybe this time I choose maybe 5 route to 1, I choose 5 to 1. Next time I will choose 5 2 4 3 1. Right? Then it's unstable. Maybe the first packet reach here, the second packet goes here, which takes longer. Right? The important thing is stableness. Right? So this is called a stable paths problem. Okay. So we also call it SPP. Right? SPP basically means stable path problem. Okay. Let me see whether we have time to cover this. I think because of the time, right? So we only have 1 minute left. I think we will talk about SPP next time. Right? I will be here for 1 minute. If you have any questions, feel free to ask. Okay. Otherwise, this is at the end of this class. Thank you and have a good day. Any questions? Okay, I'm not seeing any questions. If you have additional questions, feel free to send me email. And you can also go to your office hours or send them email. Okay. Oh, I see some chat now. Okay. All right, so I see one question. Yeah, have a good day. Confused about the fundamental purpose. So Alex, can you clarify a little bit, and then I can get a better idea. What do you mean by fundamental purpose here?
Can you just give me a clear and concise definition of what the BGN is? I was a little bit confused about.
What do you mean by BGN? We have the BGP, right? So which is the Border Gateway Protocol, right? What do you
Oh yeah,
mean
BGP. Sorry.
Yeah, Border Gateway Protocol is basically you have autonomous system. Is okay, right? You have AS. You want to route through different AS. Okay. It's basically explained in the earlier slide here. So basically, if you have an autonomous system, you can run your OSPF internally. But when you route through, right, you want to go to some destination in different areas, right? You may pass through additional areas. ZACS can be service providers, can be your peers, etc. Right? And then you need a BGP protocol to find the best route. So the purpose is to find a route. Okay, so this router knows which route you should take. Would that be okay?
Okay, so oh yeah, it just helps you find the best route. I gotcha.
Yeah, so find the router between AS, among AS. Okay. Do you answer your question?
Yeah.
Okay. Then any other questions from the students? If not, I will see you guys on Friday and have a good day. I will send this video to YouTube and you will be able to find it by today. Thank you.